Hey you guys, please like, share and subscribe to my channel PHYSICSSIRJEE, the one-stop solution for you to take an extra lead in your JEE advanced preparation. And here we are in the PHYSICSSIRJEE Quickies, where I do serve some nice nuggets and simple concepts related to IIT JEE preparation. I call it fast food for thought, and with conviction I can say this is one fast food that's harmless for students. So here we go with the today's simple concept. A, consider a uniform thin hemispherical shell of mass m and radius r. What is its moment of inertia about an axis passing through its topmost point and a periphery point of its base? So we have an axis here, thin uniform hemispherical shell of radius r and mass m. We are supposed to calculate the moment of inertia about this particular axis. Do pause the video here, give it a try for 1 or 2 minutes, and do come back for the concept and the explanation. So here I go with the simple concept that we need to use the symmetry first. I have drawn an approximate situation where I have a uniform spherical shell of mass 2m of radius r, whose moment of inertia you should be knowing about any diameter which is the line of symmetry would be coming out to be 2/3 of its mass, which is 2m into r square. Now this particular thing in my mind I can consider it to be part of two hemispherical shells with the same axis, right? Just separated it out, but this is the same axis. If you combine these two, this axis will merge into this one. So since this is symmetrical for both these situations, you could see the moment of inertia for this one and this one for this two axes should be the same, and sum of these two should give rise to this. And since they're equal and their sum should be this, individually the moment of inertia for this axis should be 2/3 mr square, which gives us a nice interesting result that moment of inertia for a hemispherical shell about any axis passing through its center of curvature, that is the center of the base, is 2/3 mr square. Okay, so with this result, we'll carry forward to find a moment of inertia about an axis which is parallel to this one and passing through the topmost point and this periphery point. Okay, so we'll take that one forward. So we have already found out the moment of inertia for this particular axis in the previous slide as 2/3 mr square. Now the required axis I have drawn with another red line in the diagram, as you could see, which is a parallel axis to this. Now in between the two axes, I have drawn another parallel axis which passes through the center of mass. You all should be, as JEE aspirants, knowing the unique nature of a uniform hemispherical shell, that its center of mass lies r/2 distance above the base center. Okay, so r/2 distance, which means this white colored center of mass axis is equidistant from these two axes. Now I'll use the parallaxis theorem, which gives me I is ICM plus mx square, and it tells us that all i's for same value of x should be same. That means all moment of inertia of axes which are parallel to the center of mass and equidistant from them should have same moment of inertia. Since this is r/2 and this is r/2, these two distances also should be same. So the moment of inertia of this and this, without any integration, you should be able to realize it is also equal to 2/3 mr square. Okay, so we'll try to search for that option in among these, and therefore you'll have this as the required answer. I hope you have liked this particular question, and here's a practice question which I'll answer in the next PHYSICSSIRJEE Quickies video. So please do have a look at it. We're talking about the moment of inertia of a square lamina about an axis passing through its corner, but it's not a symmetry line. It's making an angle of 37 degrees with its edge. Okay, so I hope you can try this one out and do comment your answer below. Till then, you can follow the rest of the series that are running parallelly in this particular channel. All the important information about this series are in the description below. Please do go through patiently through the description and you'll find a lot of gems in this particular channel. Okay, so as I said at the start, please do support this channel by sharing the videos or the content that you like, so that I can be motivated to produce more content in whatever little time I do get to produce videos in this particular channel. Okay, thank you. See you in the next one.